Okay, so today in this lecture, we'll discuss about the source transformation theorem. So we talk about the source transformation theorem. This is all about the transforming the voltage source into the current source and current source to voltage source by its equivalent circuits. We have studied the voltage source and electrical source in the previous lecture, and we have discussed about the practical and ideal current source and voltage source. In case of the voltage source, generally we have a one internal resistance connected in series with the voltage source. Similarly, for the current source, we are having a internal resistance. If it is a practical one, internal resistance connected in parallel with the current source. And I told in that class also that both of the circuit, voltage source resistance, current source and resistance, can be interchanged, can be converted or can be transformed to each other by their equivalent one. So here we'll see this method of replacing voltage source in a circuit by its equivalent current source. And similarly, we can replace the current source by its equivalent voltage source. This generally theorem is known as source transformation theorem. It's very important theorem. Suppose in Thevenin theorem, if any current source is given, if we found the suitable condition, then we convert this current source into the voltage source so that we can deal with the voltage source. Because in Thevenin theorem, we generally deal with the voltage source. So source transformation is possible only for the independent sources. It is not only limited to the resistive circuit. It can be applied capacitive circuit, inductive circuit also, where capacitor and inductor can be considered as a capacitive reactance and inductive reactance in AC circuits basically. Okay, so in that case, whenever we are talking about the capacitive and inductive circuit, we are going to convert the whole circuit into the frequency domain circuit by taking the Laplace transform. So according to that, we will deal the transformed circuit for the transformation purpose. This source transformation technique is required to simplify an electric circuit for analysis. Yes, it will simplify the problem associated with the voltage and current source. Because most of the time, if both sources are available in the circuit, it is sometimes very difficult to solve the problem with a simple method. So it's very easy if you can convert voltage source to current source or current source to voltage source. Then in that condition, the circuit will have similar type of the sources. In that case, calculation or analysis of the circuit becomes very easy. So this source transformation theorem is very much important. So this voltage source along with a series resistance is called a Thevenin equivalent circuit. Similarly, current source along with a parallel resistance is called a Norton equivalent circuit. So Thevenin equivalent circuit, that is voltage in series with the resistor, can be converted to a current with a parallel resistance, that is a Norton equivalent circuit. So indirectly you can say that it is a transformation method in between the Thevenin theorem to the Norton theorem also, without taking much more pain. So performing a source and transformation, we apply the Ohm's law, where voltage source will be available in series with the resistance. It will be replaced with a current source in parallel with the same resistance. Remember, resistance value will not be changed. Only equivalent voltage value and current value will be changed. We will see, or it is the vice versa. If we replace voltage, current source in parallel with the resistance to the voltage source in series with the resistance, vice versa. So in order for these two type of the sources to be equivalent, they should provide the same voltage and current to any load. If we convert voltage source to current source or current source to voltage source, there should not be change of the effect on the load terminal. Condition across the load terminal will be same. It will provide the same voltage and same current to the load, because we are changing we are transforming the sources only, voltage source to current source and current source to voltage source. We are not changing any condition across any load, okay, any load or any load resistance. So voltage and current sources are mutually transferable, means voltage to current source and current to voltage source can be transformed to each other. That's why it is written that it's mutually transferable, or it can be transformed one form to another form. So we will understand this concept by taking one circuit as an example. In the next slide, you can see two circuits are given. One is 20 volt voltage source in series with 4 ohm resistor, and on the right side you will find out a one current source in parallel with the resistance. Both can be interchanged. Both are equivalent to each other. This voltage source can be converted to the similar right hand side current source, and current source can be converted to voltage source. So for that purpose, two formulas are given. Suppose we are having a voltage source along with a resistance, and we want to convert it into the current source in parallel with resistance. So we use the formula in the first bracket that IP, the value of the parallel current. IP will be given by Vs upon Rs, where Vs is the value of the voltage source and Rs is the series resistance. So if we divide 20 by 4, it will give you 5 ampere. So you can see the diagram, 5 ampere current source is there, and Rp is equal to Rs. Yes, this series resistance will be equal to the parallel resistance with the current. So same resistance will be converted, that it was in the series with the voltage source. Now it will be connect in the parallel with the current source. Just what we have done, we have got the current value by dividing voltage source by series resistance. And same resistance will be connected in parallel with the current source. So in that case, we can convert this voltage source into the current source. But you can see one terminal voltage is also shown as a plus minus under the arrow sign. So terminal voltage in the current source also will be the same. This terminal voltage, basically this is the load voltage, or this is the effect coming to the load, where load element will be connected. So this voltage should not be changed. Similarly, if we want to convert current source to the voltage source, we are having a one current source of 5 ampere, one parallel resistance of 4 ohm. Now we want to convert it into a voltage source along with a resistance. So voltage is equal to current into resistance. So voltage source value will be given by Vs is equal to Ip into Rp. So current source and this resistance value will be multiplied. 5 into 4, 20. So 20 volt voltage source will be available. And this parallel resistance will become series resistance. So in that case, this parallel combination of the current source and resistance value will be converted to a series combination of the voltage source and a resistor. So by using this technique, we can convert this voltage source into the current source and current source to the voltage source. But remember one thing, if we see the voltage source here, if just after voltage source, if we get a parallel resistance before the series resistance like this, suppose here we'll get another resistance just before the series resistance. In that case, this voltage source cannot be converted to the current source. Similarly, here in the current source condition, if we get a resistance here in series with the current source before the parallel resistance, in that case also we can't convert this current source into the voltage source. So we need immediate series resistance with the voltage source and immediate parallel resistance with the current source. Then only this source transformation can be done. Otherwise, it will be a very much great problem. We can't convert this voltage source into the current source and current source to the voltage source. In this case, we can convert one form of the energy source into the another form of the energy source. Okay, so some important points are also discussed here. Transformed sources are equivalent in that they provide the same terminal voltage and terminal current to any connected load. We have seen the last slide. This terminal voltage V and terminal current will be the same in both the cases. This will not be changed. Only we are changing the form of the sources, voltage to current, current to voltage. In the transformed form also, they will provide the same terminal voltage and same terminal current to connected load. And here one more important thing, transformed sources are not equivalent internally. For example, current through the voltage across the RS and RP are not the same. So if current passing through the RS is not same, it means voltage across the RS and RP will not be the same. So to assume that they are the same is a common error. That's why voltage drop across both the resistors are not the same. All the sources are not transformable. Means note that a voltage source must have a series resistor to be transformable. I just told you that the voltage source just need a series resistance. If we get a parallel resistance in between voltage and series resistance, it cannot be transferable. Similar case, the current source must have a parallel resistance to be transformable. In the previous slide, I discussed the same thing. If we get a series resistance in between current and parallel resistance, again it cannot be transformed. And dependent sources can be transformed also.